So for this problem, we are going to graph a cubic function. So taking a look at just a few of the particulars of a cubic function. Remember that a, so your coefficient here in front, tells you if your cubic function is going to be positive or negative, or if there's going to be a compression or a stretch. For our problem, we only have a negative. So keep in mind that a positive cubic function that has a shape something like this, but a negative cubic function, which we have, has a shape like this one over here. So that's what we're going to be focusing on. Because our coefficient here is a negative, more particularly -1, there is no compression or stretch here. We're just going to be making sure that we do graph it in its negative direction. Otherwise, the next important thing to focus on when graphing this is our h and k, which comes straight from our equation here. Our h and k, which we're just going to mark over here. Keep in mind that h, because it is x minus h on the inside of the parentheses, when we grab h from our equation, we're actually going to pull the opposite sign of what it says, because that minus there is part of the equation. So we're really just pulling the 5. And then we also want to grab k over here at the back of the equation, and that's just going to be a 3. This is our starting point for our graph. We're going to start at a +5, +3. So if I do that on my graph, that looks about right over here. Now, because we don't have a compression or a stretch, we are going to have the typical points that you see in a cubic function, the same thing as x cubed. If I were to plug in 1 for x here, well, 1 times 1 times 1 is 1. So what this tells us is the next 2 points for a cubic function. Again, keeping in mind we're going the negative direction here. So from our vertex, essentially, how I think of it, we're going to go over 1, up 1 to the left, over 1, up 1, over 1, down 1 to the right on either direction. So from this point to the left 1, up 1, and then to the right 1, down 1 to do our negative movement here. We can do a fourth and a fifth point if we wanted to. If we plugged in a 2 for x and we cubed that, that would give us 2, 8. So from this middle point, we would go over 2, up 8, over 2, down 8 in that direction, which we could maybe graph here on the right-hand side. That would give us a point somewhere around there, but you can see that starting to stretch it out a little bit more on this graph. So if we connect the dots here, just following the typical movement of our x cubed graph, we're going to start here in the middle, and we're going down to the right, and then over here on the left, we're going up. And that's about how our cubic function would look. You can always keep in mind, you can always just make an XY table as well, and just plug in different values for x, plug them into your equation, calculate them, get the y values, and plot those points as well. That's always another method in order to graph almost any graph.